Here's the last examples in section 3. For this, we want to prove that this is a parallelogram. There's a whole bunch of different ways that we could prove that this is a parallelogram. The way that I'm going to choose is I'm going to choose to show that these two lines are parallel and that they're also congruent. In this case, what I'd want to do is first use the distance formula, and so I'm going to figure out what AB is using the distance formula. And if I do that, the points here are 2, 5 and negative 3, 2. So I'm going to do negative 3 minus 2 squared plus 3 minus 5 squared. This gives us, what is that? A negative 5 squared, and 3 minus 5 gives me a negative 2, so negative 2 squared, and that gives me 25 plus 4, and that's rad 29. So that's the first part. Now we're going to do the same thing for DC, and we've got 0, 0, and 5, 2, so I've got 5 minus 0 squared plus 2 minus 0 squared, and if you notice, the numbers are going to be the same as they were in the first case. We'll have 5 squared plus 2 squared, which will give us the same answer as negative 5 squared and negative 2 squared. So in this case, it's also the square root of 29. Right now, we can state that AB is congruent to DC. Now we want to prove that those lines are parallel as well. I'm kind of running out of room here, but I'm going to do it up here. The slope of AB, and again it's y sub 2 minus y sub 1, so that would be 5 minus 3, and for the other one it would be 2 minus a negative 3, so that gives us plus a positive. That gives us a slope of 2 over 5. We're hoping the other one is also 2 over 5. So we're going to look at DC, and we've got 2 minus 0 over 5 minus 0. That also gives us 2 over 5, 2 over 5. So now we can state that AB is parallel to DC. And since these two things are true, we have one set of sides that are congruent and parallel. We can say ABCD is a parallelogram. Okay? And in the second part of this, we're going to talk about other ways that we could prove them congruent. I'm just going to go over it right now, actually. Another way we could have done it is we could have done the distance formula 4 times and found out that not only AB is congruent to CD, but AD is congruent to BC. We could have done it that way, and then we would have known opposite sides were congruent. We could have done the slope formula 4 times, and then we could have said that BC is parallel to AD and AB is parallel to DC. So opposite sides parallel using the slope formula. And finally, probably the easiest way to do it would have been to find the midpoint for BD and the midpoint for AC. And if we found out that the two lines had the same midpoint, then we could say the diagonals bisected each other, and therefore it's a parallelogram. So we'll go over that as well. Again, we start off finding one set of sides congruent and parallel. We start with the distance formula to find out that those are congruent. And for the first one, just as I did, you get rad 29 there. And for the second one, we also get rad 29. So now we know the opposite sides are congruent. Now we want to prove that they're parallel. And we use the slope formula. We get 2 over 5 for AB, 2 over 5 for CD. We know the lines are parallel and that they're congruent. Therefore, we can state that it's a parallelogram. And again, we want to know what are the other ways we can prove that it's a parallelogram. We can find the slopes of all four sides and show opposite sides are parallel. We can find the lengths using the distance formula and show that opposite sides are congruent. Or we can find the midpoint for both diagonals and find out that the diagonals bisect each other. And we're done here. Thanks.